Checkpoint 7. The figure shows the phase and interface temperatures of the composite slab consisting of 4 materials of identical thickness through which the heat transfer is steady. Rank the materials according to their thermal conductivities greatest first. Let's see the given figure. You have a composite slab, and this is a complete composite slab made up of 4 different materials, A, B, and C, D. This A block, B block, C block, D block are different materials, but what is the thickness of these materials? Are identical. All 4 blocks thickness are same. And in these 4 blocks, the heat transfer is steady. Now what we have to give the answer? We have to give the answer which material will have the highest thermal conductivity value. So for this, let's just recall the formula about the conduction rate we studied from chapter number 18. Conduction rate P, which is equal to thermal conductivity multiplied by the area of the material multiplied by the change in temperature over L, where K is the thermal conductivity, A is the area of the material, delta T is the change in temperature, where L is the length of the material. So based on the information given in this checkpoint, all 4 materials are identical in thickness. That means thickness identical means let's consider the area and the length are exactly the same based on the diagram, based on the figure. So only information, we have to find the answer for the greatest thermal conductivity by using the change in temperature. So if you see this temperature, the first block final temperature is 25 degree, initial temperature is 15 degrees Celsius. Likewise, for the second block, the final temperature is 15 degree and the initial temperature is 10 degree. So likewise, you can find the change in temperature for remaining block C and D. So by using this change in temperature value, we can give the answer for the thermal conductivities. Generally, a smaller temperature drop, when you find the delta T value, if you have the less value for the delta T, that material will have greatest thermal conductivity value. So we can easily find the change in temperature for these 4 different blocks or 4 different materials. So let's consider material A, or better we can name as caps A, B, C and D. So material A, material B, material C and material D. Let's find the delta T for this material A. So what is delta T? 25 minus 15. We got the answer as 10 Celsius degree. Likewise for material B, the delta T value, final temperature is 15 minus 10 degree, you got 5 Celsius degree. For the block 3, for block C, the delta T final value is 10 degree, minus of initial degree is minus 5, so minus 5. So 10 minus of minus 5, 15 Celsius degree. But for block D, the delta T value here is minus 5 minus of minus 10. So minus 5 plus 10, its answer is 5 Celsius degree. Now you can see material A have change in temperature value 10 Celsius degree, B 5 Celsius degree, C 15 Celsius degree, and D 5 Celsius degree. So here the material C has the greatest value of delta T. That means the temperature drop is greater. That means whenever the material will have the greatest temperature loss drop, we can say that material has low thermal conductivities. So now you can see material B and D, we got the same answer, and here the temperature drop is smaller level, which is 5 Celsius degree. So if you want, so now we can easily give the answer for the thermal conductivity from the greatest value. Material B and D will have the low temperature drop, so we can say material B, which is equal to material D, have the greatest thermal conductivity value. And then material A have 10 Celsius degree, so this will take the second highest value, material A. and then the last one is C, which has the greatest temperature drop, which is 15 Celsius degree. So that will take the last place. So this is the order of thermal conductivities from the greatest value. That's it. Answer. This is the answer for this question. Thank you.